Analyzers, and welcome to your Chapter 7, Lesson 9 notes, all about graphing, logarithmic functions. We're at the end. We, at the very beginning of this chapter, talked about solving regular exponents, right? Just raising our bases to powers. And then we graphed exponential equations and exponential functions, in the next lesson. Now we're going to take our classic exponential growth function, 2 to the x power, y equals 2 to the x power. We're going to graph it real quick, just remind ourselves what it looks like on the graph. And we're going to do something to it to show exactly the nature of a logarithmic function because of the way a logarithm changes the form of an exponent. So it's very interesting how this then switches around, right? And then what that really is for us. So I'm going to start just by filling in the stuff that we know. This is, like I said, our classic growth function. So this is very, we should have this memorized by now. What's going on here? Like 2 to the first power is 2, 2 to the second power is 4, 2 to the third power is 8, 2 to the fourth power is 16, right? Heading back, 2 to the 0 power or anything to the 0 power is 1. 2 to the negative 1 flips 2 in the base and then raises it to the first power, so that would be 1/2. 2 to the negative 2 flips 2 in the base and then raises the base to the second power. So that would be 2 to the 1/4 is the answer. And then 2 to the negative third again flips the base. 2 times 2 times 2 is 8 in the denominator. So now graphing those points, 0, 1, 1, 2, 2, 4, 3, 8, 4, 16. I'm just using the classic. And I use it so much with you guys that this should just kind of be second nature. Halfway is halfway between 1 and 0, and then a fourth, and then an eighth, right? We're like heading towards our asymptote of 0, but not touching or crossing. Remember that whenever you make a graph, an asymptote is part of the graph. So it must be present, just like you must label your equation on a graph. So again, y equals 2 raised to the x power. And the asymptote here is this invisible barrier we cannot touch and cross. It is y equals 0. We are heading towards 0, but we will never touch or cross this line. And notice for an asymptote, I just did a dashed line, kind of like I do for the axis of symmetry in a parabola. Same deal. In this case, it's an asymptote. Okay. And with our exponential functions, there's always going to be a horizontal asymptote. So it's always going to be a y equals some number that we cannot touch or cross. Okay. Maybe you can see where I'm going with this. When I take and convert this into logarithmic form, when I take and convert that, right? What ends up happening so that I can have my y alone is I actually get an inverse situation, okay? Because of how this particular situation works, okay? The base was 2, the exponent was x, and the answer here was y. Well, that put a y here and an x here, and that's not something that we're going to be able to graph because we need y alone. So this inverse situation has occurred so that I can have y equals log base 2 to the x. And so what happens is to take this base and have the 2 and the x in that logarithmic form, actually you just flip around your x and y points from the exponential function. So our logarithmic functions are the inverse functions of our exponential functions. So remember back to chapter 1 when we first started talking about functions in general, we did graphing inverses of stuff where we literally just took a graph, flipped the x's and y's, graphed that result and just called it f of x to the negative 1. Now we can put an equation to it. So if you have that happening with our exponential functions, now we know, oh, that's a logarithmic function. So if you've done the inverse, flipping the x and y, that also means the asymptote has been flipped. So the asymptote on our graph was y equals 0. Now the asymptote on our graph here is x equals 0. Okay, that's what's going to be happening here. That's what's going to be happening here. Okay, so I just wanted to bring that to your attention before we just go ahead and go in and graph these things. Okay, this is the one spot where if you have a TI-84, you're going to be in a little bit better shape than if you have a TI-83, and I'll show you why in a second when we get to actually plugging these into our graphing calculator. First of all, I'm just going to go and regraph what I just did. So I'm just copying these from that front page, or, you know, have them memorized. So that's where these are really coming from, is I have them memorized, right? I'm just going to put it on the graph again real quick. I know this is a different looking graph. There's obviously a reason for that, and I'll show you in a sec. So here we go. Let's see. 0, 1, 1, 2, 2, 4, 3, 8. Backwards this way. Obviously, I won't be able to fit the 416 this time. So again, anytime I graph an exponential function, I have to label y equals 2 to the x power, and part of the labeling is the asymptote, which is y equals 0. That is the invisible barrier that this exponential function is not touching or crossing. Well, because I'm flipping this logarithmic function, I'm doing the inverse. Basically, what I just do is take the x values and now they're the y values. So these x values are 1/8 and 1/4 and 1/2 and 1 and 2 and 4 and 8 and 16. And obviously I won't be able to fit a lot of these because these are the x values, right? So the x value of 1 is right here. 1, 0 is here. The x value of 2 is here, 2, 1. The x value of 4 up to 2. The x value of 8 is the last thing I'll be able to fit on this graph right here. And now notice these guys. The x value is 1/2. Well, that's here. And then down to -1 for the y. The x value is 1/4. Well, that's here, here, and down to -2 for the y. The x value is 1/8. So notice this time I'm getting closer and closer and closer, but not touching. X equals 0. So this time my asymptote that does have to be put in and labeled is x equals 0. And then, of course, this has to be labeled with its equation now that we know that it's y equals log base 2 to the x. Okay? Think about that. Think about that. The answer for x here, let's say right here, is 2, right? So that's this x. The output is 1. Well, that makes sense. Log base 2 to the 2 is 1. So that's why, because of the form switch, this is actually an inverse when we put it in function form. Okay, that's the reason. So I'll use this purple, that trash color that you guys love so much, to just show you that this is a flip of the x's and y's. Here is your y equals x line on your graph. Right? There's your y equals x line on your graph, and it's literally just flipped right over, including the asymptote, the invisible barrier that you cannot touch or cross. Okay, that's included in that whole flip. All right? Now, you could just move these things around, right? And we could easily, I gotta stop, sorry. I'll come back to that. Could just move these around. but we're going to use our graphing calculators because, why else have them? Okay, so for exercise 3, it's going to be much easier to type into your graphing calculator if you have an 84. Okay, so if you have an 84 or an 84 CE, or you're using this program like I am, this is going to be so much easier to type into your y equals and get the points and graph it. Okay, I will show you both ways, but I just want to be really clear that only the 84s have the log base possibility. So if I want to type f of x equals log base 3 2 x minus 1 and then plus 2, I can, go to y equals for my functions, right? I can actually use the log base function that's under math. So if you go under math and you arrow all the way down, this takes care of having to know the change of base formula right here. Okay, now, because I specifically asked for change of base on the test, you are still going to need your change of base formula. Sorry about it. All my stuff is based on having an 83, right? And a couple of you still do. So sorry. Here we are. At least you have this for your graphing. So here's where I can put my base 3, and then I arrow into my parentheses, and I put my x plus 1 in the parentheses. This thing is the answer. And then this plus 2 is like off to the side. So if I'm going to do log base using this stuff, I have a specific way I need it to look, and I will show you that in a sec. Okay, but this is how I can type in the function using just the log base function that comes in the 84 calculators. Now, if I don't have an 84 calculator, but I still want to graph this thing, you can, and it's easy, but you need to consider that you're going to have to change this using change of base. Okay, so you're going to need to change this, and if this is y2, we're about to enter for y2, you need this to be, let me do the change first, log of x minus 1 divided by log of 3, the base, and then plus 2 on the outside. So when you go to type this into your graphing calculator using change of base formula, you're going to need the big parenthesis, log, and then a small parenthesis, x minus 1, and then divide by log, and then you're going to get a parenthesis 3, and then an outer parenthesis like this, because this stuff, notice this parenthesis goes together, this parenthesis goes together, this parenthesis goes together. And then you can do your plus 2 on the outside for that particular movement, okay? Because this plus 2 is not part of the answer. What we're saying by having this in parentheses here is that this is part of the answer. This is that plus 2, which is moving it up the graph, okay? So you want to be really careful about it when you go to type it in. So I'm just trying to make that really clear now if you have an 83 and have to use this. So that parenthesis that's just started is where you put this x plus 1. This is where you end that, and then divide by the log of 3, and then you end that, and then you have one more parenthesis here that ends the initial front. Okay, so just make sure each is closed. That's why I wrote it out here so you can see it. And then you can put your plus 2. Okay? So when I graph these, you're obviously going to see the same function graphed twice. Okay? So just proving to you that with an 83, it's not that much worse, but you really need to make sure you know that change of base and you're getting things in the right spot. Okay? It's not that much worse. You can do it. Oh, getting all these errors, right? Well, if you look back at the graph, just real quick, that's because all the stuff that's over here does not exist. It's on the other side of the asymptote. See, I can see that my vertical asymptote, my straight up and down asymptote, is right there at x plus 2, right here. Okay, it's right here. That's my asymptote. And that's this moving it over. Okay? No, sorry, x plus 1, right? Hold on. Yeah. Because I got 2 here. -1. That's where my error is. So x equals -1 is my asymptote. I said that backwards, my bad. X equals -1 right here is my asymptote, and that's why we get close to it right in front right here, but then we just kind of have it like disappear because it's getting too close to continue to show you, okay? The +2 is the fact that this is moved up here to 2 on the on the y-axis. All right, so looking at those things, I could make those determinations, but I'd rather see it on the table. So table again, we'll put the first error because that's always going to be our asymptote when we do our table. Probably have to pull my graphing calculator back so we can see our graph again. We'll write the first error. Okay, and then after that, the integer points that we can fit, that's what's going to work. So 0 and 2, and that's why we're up on the y-axis at 2. That's this +2 at the end right here. That's what pushed that guy up. And then, of course, we've got 2, 3, and then what's the next one going to be? Notice, by the way, we've got all these decimal points. I'm not going to worry about those. I'll get to 8, 4. Okay, and that's where I'm really going to be able to stop. I'm not really going to be able to fit any more points. And that does make sense because it's the inverse of an exponential. You're not fitting a lot of these with an exponential either. Okay, but the next one up to 5 as a y value is going to be way up here at 26. So obviously that's not going to fit on the graph. So when it comes to graphing a logarithmic function, you're really not going to be able to fit a ton of points because this is the inverse of an exponential where you really can't fit a ton of points. Okay, so let's start graphing. Our asymptote is here. So x equals -1 is our asymptote. Hello, I said I needed to move it and then I didn't do it. Now we'll get these other points up here. So 0, 2, and 2, 3, and 8, 4. All of those make perfect sense, right? And if we're talking about heading toward the asymptote, that's the direction we go. Arrow on that last point that fits. Show yourself heading toward the asymptote. Do not show yourself touching or crossing it, and you're fine. You're perfect. That's all you need to do. Okay? Then stop right there, and it's f of x equals log base 3 to the x minus 1 plus 2. Just like that. That's plenty. Okay? That's enough points, 2 or 3 points fitting on the graph and getting the asymptote and labeling with your function equation is plenty to show the nature of this logarithmic equation. Okay? It's the inverse of having y equals 3 with the base, x minus 3 in the up in the exponent, and the plus 2 has moved this function up 2 on the y-axis. And so that's what you're seeing is it's just the inverse of that. All those x and y's have just flipped over. Don't worry about graphing these in-between decimals. Just worry about graphing those integer points and getting the idea of the function on the graph. Okay, just worry about that particular part. So, of course, I just want to show you this one more time, is that when transforming logarithmic functions, it's the same types of transformations as far as moving up, down, left, right. Okay? You're just thinking about them in terms of that other scope rather than this scope. We're thinking this scope. Okay? So that direction, that inverse. And again, that's how all the transitions look. Do I need you to memorize this the way that I've talked about it with quadratics and the way that I've talked about it previously with the exponentials? No. Okay, no. Outright no. Use your graphing calculator. Get it that way. I'm fine with that because you're going to have a graphing calculator when you do this stuff. Okay, so that's absolutely fine by me. But I still want you to see those differences. Okay, and so that's what all these parts of the notes are, is look at the differences in the equations when those changes get made. Okay, look at when an asymptote moves. An asymptote moves when this value inside the answer part is changed. So if in parentheses your x has a plus or a minus, your asymptote is moving to those spots. If you add or subtract On the outside, it's moving it up and down. And so that is exactly the same as how those shifts happen in a regular exponential equation. That's the same exact thing, okay, or a regular quadratic, right? So you can see why these things happen and how they happen, okay? And again, you always have the option of plugging into your graphing calculator. This is not stuff you need to memorize. This is just us showing you that relationship between the equation and then what points come out of it. So you're not completely, thrown when you see what you plug in to the graphing calculator. Okay, so when you see that happen and get on your graph, you're not thrown by it. Okay, so just some pieces. Again, just wanted to show you log base 2 compared to ln compared to log base 10 and how those all look. They all have that specific change to them, so that's nothing new, nothing you're unfamiliar with. But notice all your asymptotes are vertical, straight up and down, like an axis of symmetry is. So they're always going to be x equals. Okay, so your asymptotes for logarithmic functions are always x equals. Remember, this is just the inverse, and I'll go right back. This is just the inverse of your exponentials. So this is a flip of your x's and y's in your exponential functions. Okay, that's what's going on here. Okay, so you have the idea of what happens with exponential functions. Now just flip that over. This is the idea for your logarithmic functions. All right, guys, use that graphing calculator to plug into y equals. Otherwise, I think you're all set with this. And yeah, time to get ready for our Chapter 7 test. So I'll be seeing you guys. Bye.